Alright, finally we're at the last video of this section, and this is actually pretty cool because this will show you where some trig identities come from. So suppose you wanted to rotate 2 theta through an angle of 2 theta. Rotating an angle of 2 theta would have a matrix of, let's see, it'd be cosine 2 theta here and here, and minus sine 2 theta here, and sine 2 theta here. But if you think about it, you could also rotate 2 theta by rotating theta and then just rotating theta again. So you could say this thing squared, or let's actually write it out. So this will be cosine theta minus sine theta, cosine theta. Now, if you take these guys over here and multiply them out, we'll get something. What do we get? Well, when we do this times this, that's going to give us cosine squared theta minus sine squared theta. When we do this is going to give us, let's see, cosine, it'll give us cosine times negative sine, and cosine times negative sine again. So this is minus 2 sine theta cosine theta. And then when you do the bottom row, this times this will give you, again, 2 sine theta cosine theta. And when you do the last, that's going to give you minus sine squared theta plus cosine squared theta. Now the really cool thing is this matrix and this matrix are equal to each other. So what you can extract there is from this position you get cosine 2 theta is cosine squared theta minus sine squared theta. And from this position here you get sine 2 theta is 2 sine theta cosine theta. And those are trig identities that you should have seen at some point before. A lot of the time, well, maybe I shouldn't say a lot of the time, but I have this one memorized. This one always, I don't know, for some reason I don't have it memorized. But this is one way you can derive those. And if you wanted to find, the stuff for cosine, sine and cosine of 3 theta, you could just multiply another one on here and get that. You can also use this to come up with the addition formulas. Cosine of alpha plus beta you could do this by putting in rotating alpha and then the rotation matrix for beta. And you can derive those just as well. I'm not going to do it because it's more tedious stuff. But anyway, this is a cool way you can derive some of those trig identities that you've seen before. All right, that's it.